I was just silent when you said that. You didn't know.
I'm recording.
Praise.
Section 2.8, function operations and composition. We're gonna do arithmetic operations on functions, difference quotient. Difference quotient is probably the area that might get you the most if you're not careful. A composition of functions, a lot easier than people make it out to be initially. We will not finish 2.8 today, we will finish 2.8 tomorrow. So this graph shows the situation for a company that manufactures DVDs. You see two graphs on there. The R of X line, the red line, that is your revenue line. And R of X is equal to 168X. The blue line is your cost line. And that cost function, C of X equals 118X plus 800. Where X is the number of DVDs produced and sold. And X, R of X, and C of X are given in thousands. So 30,000, that would be represented as 30 on the graph. So the profit, the main reason a person goes in business is to make money, right? And so how much money do you make? Well, it's what you spend subtracted from how much money you bring in. So in the case here, we have the P of X, that's the profit. P of X is equal to R of X, the revenue, minus the cost of goods. Plugging in 30, you plug the 30 into the R of X function. So you have 168 times 30, which is 5,040. And you also plug 30 into the cost function. 118 times 30 plus 800 is 4,340. Then you take those results, 5,440 minus 4,340, and you get 700. Which means by selling 30,000 DVDs, we're going to profit $700,000. And that is arithmetic operation on functions. We're plugging the same number into two different functions. Just out of curiosity, does anybody have any idea what that point right there would be called? It is, mathematically, we call that intersection, but let's put that in the business world. I think I heard it. What'd you say?
I said winning one time.
No, I thought I heard it. Did you say something? What's that point called?
Can we get a hint?
The money spent is equal to the money that you brought in.
Sure. It's like an equal. I don't remember the name of it.
Okay.
I think you told us this a while ago.
I'll get it. Hold on.
Can you
Biggs.
tell us? What does it start with?
Yeah.
Yeah, what's the
Two words. First word starts with a B.
Break even.
Break even.
Oh,
Yeah.
darn it.
So if I'm in business and I hit that point, I haven't made any money, but I haven't lost any money, right? That's a good thing. Down here, that would be a bad thing. I'm losing money, right? So a company's goal, the number one goal is to hit break even. And then above that, now we're going to make our investors happy by making more money. So here are the things you're going to see. And most of you have already seen this. I really appreciate the fact that there's so many of you in this class that have been working on 2.8 before we even get here. This does not mean f function plus g function times x. That's not what this means. This means I'm going to take the f function of x and add it to the g function of x. That's what it means. I'm adding the two functions together. This means I'm subtracting the two functions. I'm multiplying the two functions, and I'm dividing. Now be careful on the dividing. Whatever you're dividing by cannot be 0, because you just can't divide by 0. The bottom part says the domains of f plus g, f minus g, and fg include all real numbers in the intersection of the domains in f and g. What the heck does that even mean? Let's say I've got some function, f of x. And let's say I've got a restricted domain. The domain on f of x goes from this point here, I'll give a number to it in a moment, to this point here. Let's say that it goes from -6 to 15. Can I plug -5 into this?
Yes.
Yes. Can I plug -10 into this?
No.
No, because negative 10 is not in the domain of f. Okay? Can I plug 12 into it?
Yes.
20.
No.
20 is not in the domain of f. Can I plug in 15?
Yes.
Y'all following that? Pretty simple. Okay, let's say I've got another function. I'll call it g of x. And g of x has a domain from, say, 12 to, I don't know, 25. Can I plug 12 into the g function?
Yes.
Yes. Can I plug 18 into the g function?
Yes.
Can I plug 25 into the g function?
Yes.
Can I plug 10 into the g function?
No.
No. So the domain of g is only from 12 to 25. Now let's talk about the composition. Let's talk about adding f and g together, or subtracting them, or or multiplying them. Okay? The domain is the intersection. (12 to 15). So can I do f plus g of 8? I'm saying yeses and nos. Can I do f plus g of 8? Does 8 work for f? Yes. Does 8 work for g? No. 8 is not in the intersection of f and g, therefore, this right here would be not defined. And that's what it's saying down here. It's when the domains of adding, subtracting, and multiplying include all real numbers in the intersection of the domains of f and g. While the domain of f divided by g includes those real numbers in the intersection of the domain, and g is not 0. Okay? So, for my example, all I know is what the input is. I don't know the outputs. Okay? And that's what we're talking about there is the output. The output of g cannot be 0. Can x be 0?
Yes.
Sure, it could be, right? But it can't, once you do that math, you can't equal 0 because now we're dividing by 0 and that's a problem. Okay? All right. We're going to do 2 problems with these 2 functions, f and g. F of x is x squared plus 1. G of x is 3x plus 5. And I want to know what is f plus g of 1. Again, what that means is, what is f of 1 plus g of 1? Okay? Which means I'm going to take that f function, and anywhere there's an x, I'm going to replace it with a 1. So there's the f function. The f function is 1 squared plus 1, plus the g function, which is 3 times 1 plus 5. Simplifying these, we get 1 plus 1, 2, plus 3 plus 5 is 8, and we get 10. Questions on that? If I was doing a whole bunch of problems, let's say that I had to do f plus g of 1, f plus g of 8, f plus g is negative 6, f plus g, a bunch of them. What I would probably do is find out what f plus g of x was first and then plug it into that. Meaning if I had f plus g of x, I would take the f function and the g function, add them together and get x squared plus 3x plus 6. Do y'all see that? What happens if you plug a 1 into this? 1 squared is 1 plus 3 times 1, 4 plus 6.
10, 11.
Isn't that what we got? If you plug the 1 into this, you'd have 1 plus 3 plus 6. 1 plus 3 plus 6 is 10.
I don't care too well with basic math.
Do what?
I don't care too well with basic math.
Part B, we have f minus g of negative 3, which means f of negative 3 minus g of negative 3. Plugging in our values. Anywhere there's an x, I'm going to change it to a negative 3. So I have negative 3 squared plus 1 minus 3 times negative 3 plus 5. After cleaning this up, negative 3 squared is 9 plus 1 is 10 minus 3 times negative 3 is negative 9 plus 5, negative 4. So I have 10 minus negative 4, which gives me 14.
I like this.
Questions on that? So that was adding, subtracting, same f and same g. We now have multiplying and dividing. By multiplying, this means f of 5 times g of 5 . 5 squared plus 1 times 3 times 5 plus 5. Five squared plus 1 is 26
20.
times 20. 26 times 2 is 52.
5,000.
Add a 0. You get 520.
Oh. See what I mean? Basic math is not easy. I only took it for 5 years.
And part B, which have f of 0 divided by g of 0. F of 0 is
1.
1,
5 by
g of
5.
0 is 5.
Wait.
Uh-huh.
Hold your forces, sir. I'm still understanding. Not very much.
Wait, what? Oh, wait, just kidding.
Do what?
Just kidding.
Yes, sir.
How'd you get the 1?
The 1 and the 5?
It's 0.
If x was 0, that's basically gone.
Oh, okay.
If x is 0, that's gone.
Wait, let me just write that stuff out, because future me is not gonna do that.
Hey, Lonnie, what are you mumbling over there?
I was telling you to wait so I can write that out, because future me is not gonna remember that. Okay, I'm done.
Tell future me to catch up with us.
Right now, me is not catching up with you.
4 more problems. We have different values for f of x and g of x. But now we're not plugging in numbers. We're just dealing with just the functions. Letter A has f plus g of x, which means the same thing as saying what is f of x plus g of x. F of x is 8x minus 9. And g of x is the square root of 2x minus 1. Those parentheses don't do anything for us. Do we have any like terms that combine? No? Okay. So this could technically be the correct answer. 8x minus 9 plus the square root of 2x minus 1, because that is f of x plus g of x. Or somebody might say, you know what, I don't like having a constant in the middle. I want the constant at the end. Okay, fine. You could write that as 8x plus the square root of 2x minus 1 minus 9. But based on what I saw yesterday, is the computer going to accept that answer or the first one? I don't know. You know, it might want you to just stay right here. We found out the hard way on the division problem. We actually did the math and it didn't like that.
So what did it want you to do?
I'll show you when we do part D.
I know.
Well, there's really no math that we can do on this one. I was back there with Summer and we actually did the long division. And the computer says, though this is the correct answer.
Yeah, you had to just put it in.
Yeah, we just
I
leave
did
it.
that too.
Leave the numerator, leave the denominator, don't do the math. And I was happy with that, whatever. F minus g, that would be f of x minus g of x. F of x is 8x minus 9 minus g of x, which is the square root of 2x minus 1. I can just drop the parentheses on this one too, and we'll be good to go. So we have 8x minus 9 minus the square root of 2x minus 1. Or if you want to write that constant at the end, 8x minus the square root of 2x minus 1 minus 9. And for Leilani, I will hold my horses.
No, you're fine.
Make up my mind.
No, I finished writing it. It's just I had to write a note on that other one
Gotcha.
that it was a 0.
We good? Questions so far? Pretty simple. Everybody's happy? Good. Good, good, good. F g of x, well that just means f of x times g of x, which means 8x minus 9 times the square root of 2x minus 1, and on your homework, that's what the computers want us to leave it there.
Awesome.
Don't do anything with that. Personally, I would distribute the square root of 2x minus 1. That's what I would do. But it's probably going to tell you that's, though this is the correct answer, that's not what I'm looking for. So that's acceptable. And part D, f divided by g of x is the same thing as saying f of x divided by g of x, which is 8x minus 9 divided by the square root of 2x minus 1, and leave it alone. Even though I don't like the square root and bottom, I would want to do something else with it, but they're saying no, so okay, fine.
Don't you create the homework?
I'll play their game. The homework? No, the homework's right off the book. if possible, use the given representations of functions f and g to evaluate f plus g of 4. Take a close look at A, B, and C and tell me how they're different.
First one, the graph, the second one,
Okay, so we have a graph, a table, and equations. How else are they different? Or are they different?
You tell me.
They're all the same.
What?
It all represents the same information. Okay? The blue line, the equation of that blue line is 2x plus 1. The equation of that red curve is the square root of x. Okay? Now we have some domain issues. Part B, the domain only has 4 numbers to it. The domain on part B is -2, 0, 1, and 4. Where the domain on A and C for the f function is all real numbers. And for the g function, it's x is greater than or equal to 0. Okay? You see the difference there? Part B only gives you specific points. Okay? This question says, what is f plus g of 4?
Yes.
Okay?
Oh, wait, the-
So let's look at what A would be.
No.
I'm gonna go ahead and slide this up real quick. Kind of harder to see in the back. Down that low.
Oh, you're taking the 9 plus.
Okay. So if I'm looking at the f function, f of 4, the x value of 4 is right here. On the graph, I go up and I find that f of 4 is 9. Y'all good with that? And if I do the same thing on the g function, g of 4, here's 4 again, go up to the g function, and I'm at 2. So 9 plus 2, 11. Look at the table. Here's 4. F of 4 is 9. G of 4 is 2. 9 plus 2 is 11. Plug them into the equation if I gave it to you as an equation. 2 times 4 is 8, plus 1, that's 9. Square root of 4 is 2. 9 plus 2 is 11. So it doesn't matter which one of these you do, you're going to get that f plus g of 4 is equal to 11. Questions, comments, concerns, cares, complaints? Cassidy's, I'm throwing Z's out there.
Why do we use F and G? Why not like A and B? Wouldn't that make much more sense?
It's called function notation, so they started with that.
So where did you take it?
It's after F,
Oh,
like immediately after. Yeah, it's very common. F, G, and H are the 3 most common for function notation. And indicate that they're different. Instead of saying Y all the time. Another problem looks just like this one. Except for subtracting, different value, and so on. Okay, so we have the same function, we have the same graph, we have the same table. I want f minus g of 2. What's the of negative 2? Do you see a problem with negative 2?
Yes.
Yeah. By looking at the table, we see that g is undefined. By looking at the graph, when we're at negative 2, here's an f value at negative 3, but where's the red function over at negative 2? Doesn't exist. Can't do anything with it. C, you could probably get away with it. You can just plug it in and go. Or could you? What's the square root of negative 2? What is the square root of negative 2?
No, I,
Dimension.
So there's an I, right? So it's not real.
yes,
So we can't graph it.
yes.
Okay. So the answer to this question is undefined. In all three situations, it is undefined. I don't see a graph there. It doesn't exist on the table, and it doesn't work with the equations. You know? Moving on. F times G of 1. We're multiplying F of 1 times G of 1. What do you get? 3. How many of y'all went straight to the table? Who plugged it into C? Who looked at the graph? Okay. So the 1 value is here. There's a 1 and a 3. 1 times 3 is 3. 1 times 3 is 3. 1 times 3 is 3. So FG of 1 is 3. Okay, moving on. Write down the answer.
Sir, I have 5 minutes left on my Chromebook.
That's right. Yep. Want good enough?
I did, that's why.
Trying to get my attention. Yeah.
Katie,
I got 4 minutes left. Thank you.
Where you at?
Either this or that.
You are correct on one of those.
I think it's the first
Yeah.
one.
What are you thinking?
whole bag.
And, what are you doing? Oh, 2.
What does this mean?
Wait,
To get rid of
F of 0
Divided by 0.
divided by G of 0.
1.
What's F of 0?
1,
1. What's G of 0?
0.
0. So it's undefined.
And how do we divide by 0?
Yeah.
We don't.
Take away 0 and then add the 0. I actually had somebody try to explain how to divide by 0.
Let's think.
Well, it's impossible, so they're wasting their time.
I was wasting my time because I was interested in what they were saying.
I saw this video of this guy. There's a math teacher, and he's like, how to do 1 + 1. And then he got it all the way. And he's like, so, anyways, 1 + 1 is 1. But like, he did correct math, so it's kind of funny. I have the video saved.
Okay. That's like me telling you that 1/3 + 1/3 + 1/3 is 0.999999999.
Because it is. Wait.
Wait, 1 + 1? Did you say 1
Hold
+ 1
on.
is 1?
1/3 + 1/3 + 1/3 It's 0.99999.
No, that's relativity, because that could be 1/3 of a whole, or could that be 1/3 fraction?
No, but.
Because 1/3 can equal 0.33 if it's a third of a whole.
Okay, so it's.
Moving on.
It's two though.
Something's wrong with it.
Yeah.
But then he just one. And so
We
you're
let
like,
x f
Wait,
x. Is that what this is?
Okay. Suppose a point P lies on the graph of y equals f of x. And suppose h is a positive number. We let x, f of x, denote the coordinates of P, and x plus h, f, x plus h, denote the coordinate of Q. Then the line joining P and Q has a slope.
Break it down for me.
Okay. So look at the picture. This right here is some point. Has an x value of x. Yes.
Can you move it up a little bit and see it?
You did it, right?
I think I can do this to do that. Oh boy. Okay, so this point has an x value of x. To get the corresponding y value, we plug x into the function to get f of x. I'm going to go to the right, some h value, which means this x value is now x plus h. I don't know what the value of x is, but I added h to it. So the x value here is x plus h. I'm going to take that x plus h and plug it into the function, which gives me f of x plus h. This graph is some curve. Putting a point, 2 points on that curve and drawing a line through that curve, that line intersects the curve, touching that curve at 2 different points. A line that touches a curve at 2 points, by definition, is called a secant line. So this is the secant line that goes through this. Slope can be found by using the formula y2 minus y1 over x2 minus x1. Is that new to you? Not at all. The y value here, this is 0.2. This is f of x plus h minus f of x divided by x plus h minus x. Y'all good with that? This is the slope of that line. Look at that denominator. X plus h minus x. What just happened there?
You just took away the f.
X minus x is gone. So all I have left in the bottom now is h.
Oh, you're talking about
That makes sense? Now it says here that h can't be 0. Well, duh, you can't divide by 0. And duh number 2, if I give you 1 point, can you draw just one line through that 1 point? How many lines can you draw through 1 point?
Infinite.
Infinitely many. How many lines can you draw through 2 points? One line. That makes sense? This is called the difference quotient. F of x plus h minus f of x divided by h. If the math is right, if the algebra is right, the answer to most difference quotients won't be a fraction. Okay? We're about to do one. Go back up. Nice. Okay, so if anybody's doing screenshots or whatever, there's that slide back. There's the slide back.
just gonna take a couple.
Okay, so now we're going to do a difference quotient problem. Let f of x equal 2x squared minus 3x. Find and simplify the expression for for the difference quotient. And there's the difference quotient mentioned again. It's f of x plus h minus f of x divided by h. Guys, when I'm doing these, I don't do it in one step. You know, I treat it like eating an elephant. I do it one piece at a time, one bite at a time.
When do you?
Just last week.
Oh, yeah.
Yeah, it was cold.
Hmm.
So the way I do it is I start off by finding what is f of x plus h. What does that mean? Well, that means take the function, and anywhere there's an x, you replace it with x plus h, right? So my function is 2. Here's an x, so times x plus h squared minus 3 times x plus h. What is x plus h squared?
Where x equals square.
It's not x squared plus h squared. Y'all are killing me.
You gotta foil it.
Gotta foil it. Don't forget the oi.
Gosh,
X
I love it.
squared
2 times x squared plus
h squared plus
2hx, because outside times outside is xh, inside times inside is also xh. So I have xh and xh. So there you go. We have 2 of them. Plus h squared. I can distribute that 3, so minus 3x minus 3h.
That's an x. See,
Clearly an h.
I got you this time so they don't make fun of you.
Distribute the 2. 2x squared plus 2hx plus h squared minus 3x.
Wait, do you distribute that 2 to the whole thing or just?
Only what's in parentheses.
You only get to the x squared.
Uh-huh. I'm so
That's
confused.
clearly a 4.
I'm trying.
The 3h should be. It's a 3x.
Yeah, you did 3 x's.
You're doing,
Corey.
you're doing really good, I promise. I don't understand anything, but you're doing amazing.
Change this to a 4. Put a 2 here and an h here.
Good job.
And let's finish it tomorrow.
That was very difficult.
I'm not gonna lie, I was trying to I was thinking for a second that you were right, I was wrong as usual. And then I had to rethink.